So example 1 looked at things graphically. Example 2 is starting off with an equation, so this is looking at things algebraically. So remember, algebraically, if we want to find an inverse, we first switch the x and the y, and then 2, solve for y. So algebraically, step 1, I would write x equals negative y squared plus 4. And then if I was solving for y, that would mean, can I get my y by itself? I'm going to move the 4 over, multiply both sides by a negative 1 to get the y squared by itself. And then to get y by itself, I would have to square root both sides. Remember, when you square root both sides, to include the plus or minus. Part B says sketch the graphs of both of them. So this is where we're going to use some of our skills from earlier on in transformations to do this. I am going to graph the original one in green. So the original one was negative x squared plus 4. And negative x squared plus 4, can you see that this has a vertical reflection and a translation 4 units up? Everything is outside of the function. I think about my normal parabola. I do a vertical reflection, which would flip it down, and then I shift it up 4 units. There is my parabola. Now when I go to sketch my inverse, and I'm going to do that on a separate graph here, plus or minus negative x plus 4, there's 2 ways that you could sketch your inverse. My recommendation would be to use the note that we did right now. How do we use the graph to sketch an inverse? We would reflect over the diagonal line and we would switch our x and y coordinates. So instead of 0, 4, can you see that you would have 4, 0. And instead of 2, 0, I would have 0, 2, and instead of negative 2, 0, I'd have 0, negative 2. And we would get a sideways parabola. Now technically, you could have also graphed these using the equation, but it would have been a little bit harder. I'm going to highlight the top part of this in purple, and I'm going to point out that this top part would be positive square root of negative, and I'm going to write it in factored form to remind you of factored form. This would be a square root graph, the purple one, with a horizontal reflection, and then translated 4 units to the right. And on the bottom here, this would be, if the plus or minus, you'd have to actually graph them separately. The bottom one is also a square root graph in factored form, would have a vertical reflection and a horizontal reflection. and then move 4 to the right. So can you see that? Square root, flip this way, move 4 to the right. That will be the bottom. But in this situation, I think you might have forgotten to do the factored form. And you might have forgotten to split it up into two different ones. It is much easier to use the inverse idea of all that's happening is my x and y coordinates are getting switched. So if I can graph my original, which wasn't hard at all, then I can graph my inverse. Is the inverse a function? Does it pass the vertical line test? No. It is not a function. So circle questions 5 and 6.